Hello, good morning. This is Krishna. Uh, who am I? I have I've been working in finance industry for a decade right now. I've been working at Fidelity, AQR Capital, some of the biggest hedge funds, and some of the biggest fund administrations. Currently, I'm at HeadServe, building infrastructure for them, and it's been something I've been doing for a decade right now. Um, What's my expertise? I build trading platforms for finance companies and also all the back end and also the cloud infrastructure and all of that. Now, coming to um, this is a cost agent that we're building in-house, and also it's one of my idea that I proposed in the company, and we're kind of working on it. What it does is basically we're trying to solve the cloud costs that we have with large data sets, processing all of them, and basically day in day out compute tasks that we have. We currently use most of our infrastructure runs on Kubernetes and also some other infrastructure, legacy ones and on-prem and all of that. What we're not able to do is use Spot instances properly so that we can save costs on them. Usually, Spot instances give us like 80 to 90% cost savings compared to the same instance when we use on demand in AWS or any other cloud we use. So there are a lot of problems with Spot instances, which is why we don't use as heavily as we use other instance types. So this framework that we built is going to help solve that. What it's going to do is it's going to orchestrate all of the compute tasks, data processing tasks to start with, and there is much more to come around those things. Um, like I mentioned, what is the major problem we're trying to solve is the first one is orchestration. Obviously, we don't want someone to day in, day out, shaping the pipelines or infrastructure, changing it manually or using some code. We want an agent to basically handle all of it if possible, and also in a most cost-effective way if we can provide a framework around that. So how does a traditional data pipeline works? We let me yeah, sorry. So usually there are a lot of ways. We have Informatica or some other tools that we usually use, but nowadays, from last 5 6 years, the framework that we use is we have a orchestration called step functions in AWS. We have system coming through that, and then Lambda handles, Lambda starts, and then it submits the jobs to EMR, which is a MapReduce framework, or some other types of data processing engines like EC2, Kubernetes, wherever we want to start those things and all of that. And then we use on-demand instances because obviously Spot instances are not reliable, and big uh, jobs need big instances, and we also need Spark or some other frameworks running on them with pandas or all of those things. So we need an instance which is bigger in size. It can't run in Lambda, so we need EC2s, and we also need to make sure that whatever we spin up is going to run for sure, so that we don't lose it. So we never use Spot for data processing. We hardly use Spot in any data processing pipelines that I ever saw in financial institutions. We do use Spot a little bit with some compute for some ad hoc compute, but rarely. And so this is a cost. What does it cost to run traditional pipeline? So let's say you choose an M5X large, and you're spinning up on ECS, EC2 basically, and then you have some 50 containers spinning up. It's like $230 a day. That's going to cost to run those jobs. and then you spin up the same thing on an EMR. Obviously, EMR is big size. It comes with all of the Hadoop framework that we need for data processing and all of that. So it's going to cost us some $576 a day if you go with 10 nodes and all of that. So this is all on demand. We're not using any Spot instances here. And basically, the way we set up these pipelines is we go from min to max. Let's say we're gonna get like 100 GB of processing today, and there is also a chance of getting like 500 GB files some point of time. So what we need is a framework or a pipeline which can handle both of them. So we go choose like the maximum instance possible, which can handle 500 GB. But if that instance is only happening like one time in a month, you're basically paying for the rest of the 29 days to do the same stuff for lesser data. So, and we have rules on how the optimization work. Let's say you start with 2 instances or 3 instances, and as much as the compute that you need, there is like auto scaling groups that can scale these pipelines and spin up instances and all of that. But they're not fast enough. They don't choose properly because it's all predetermined, saying this might happen, so do this thing, and we deploy those changes using Terraform and all of that. And that stays like that. We never look into it. Once it's deployed, once it's productionized, we hardly look into those things again, since it's in production. And we what we do is we try to avoid as much as touching it, even though it's costing us. So yeah, the cost agent solution is basically a language model powered orchestration. So what we're trying to do is we're trying to move from Kubernetes or some other. I'm not saying we're trying to move from Kubernetes. We're just trying to put an orchestration platform where we're saying an agent can probably better handle a small pipelines, not the application backend compute or something, but it can handle small pipelines in a cost-effective way. So that's what CostAgent is. It's a multi-agent orchestration platform. It basically decides which instances you use on the fly, depending on the files that it gets, depending on the sizes of the files and all of that. And then it chooses mostly Spot instances so that we have all the savings that we have. And also, it's not like it can't choose on demand. It also chooses on demand if sometimes Spot instances, doesn't matter how much we try, we don't find them because they're not there. But we don't want the pipeline to fail, so we have like a backup failure to on-demand instances if there is no Spot available. And then there is like continuous learning. One of them would be like, let's say your job ran like for a 100 GB file, your job completed in half an hour today, and tomorrow, like after a few runs, you store all of the data in DynamoDB tables, and let's say you have a new job, and if the job is taking like maybe 1.5 hours, it shouldn't take like, because in the past it took 30 minutes, now it's taking 3 times that. So the agent sees that and it says, okay, it might have chosen a wrong instance in the past, so it goes to like choosing the right instance, it learns from those things and optimizes accordingly. Yeah, this is basically a comparison of what we do traditionally and what this framework is trying to do. Both use step functions, but the entire orchestration is moved from step functions to LLM agents, and these agents basically decide how many instances it needs, where to run, and all of that. So as I said, multi-agent architecture, we have like few things that needs to happen in this framework. One of them, the initial one was a prediction agent. It needs to determine when it gets the file, it needs to determine what it needs to spin up, or how many instances it needs to spin up. And then there is a selection agent. So the selection agent is basically, let's say it wants to spin up some m5.x large instances. but it also needs to see like where is it cheap right now, where is it cost effective right now. Is it in US East 2, East 1, or some other region AWS has? It needs to determine basically where we can get the most cost effective ones, and also if we have data located there. So all of this needs to go in picture, and then decide accordingly. um, there is a migration agent and learning agent. It's basically sometimes spot instances get killed. We will have a 2-minute notice before the spot instances get killed. So we don't want the framework to start again from the starting. We want the framework to say whatever it completed out of that, to save it somewhere, and then initiate the job from then. Um, so that's what the migration agent does. Let's say in 100 GB file, the 50 GB of the processing is done, but the instance wherever it's running is getting killed. It's going to store all of that information somewhere in the framework, and then the next instance that spin up reads it and then starts from there, so that instead of doing the 100 GB again, it starts from the whatever it's mining. Learning agent, like I mentioned, it learns from the previous pipelines and act accordingly for the selection agent. um, yeah, this is basically explaining the agent stuff. The architecture. So most of the architecture will be run on ECS Fargate. So ECS is basically a AWS version of Kubernetes. It's a container service framework, and the Fargate is basically handling them with that. EC2 Spot Fleet. So we're gonna. This is all on AWS, so we're gonna use EC2s. Um, and then step functions, which orchestrates agent workflows, lambdas, which runs the jobs, DynamoDB, which stores all of the processing jobs information, um, and the event bridge, like let's say a spot instance is getting terminated in 2 minutes, you got to know that information, and then you got to integrate accordingly. Okay, so what are we going to save? We're definitely going to save at least a 70% if we use this framework instead of using like some other on-demand framework that I mentioned, because the obvious cost savings is coming from the instances itself, because an EC2 instance on demand might cost like $10, but the spot instance is going to come around like 80% or 90% cheaper. So that's the obvious savings we get. We're just handling the headaches around it with this framework. Um, we are basically testing out normal processing jobs, but it can be any kind of processing job. It can be financial data processing, or any kind of ML video processing or data processing jobs. Anything can be done using the framework. All of them is going to be Spark jobs on your own EC2 instances. This framework is just going to orchestrate where it needs to run, what instance it needs to run, what AMI it needs to select, all of that. Um, yeah, so this can be used in multiple ways. So one of them would be like single repository, single responsibility, one agent, one job, clear interfaces, because as I said, there is like a multiple agents here. But each agent has its own responsibility. There's like selection agent, there is prediction agent, there is some other agents in there which can select whatever responsibility it needs to do, and move on from there. Everything will be logged. Everything will be into DynamoDB. There's CloudWatch logs, there's CloudTrail logs. Everything will be there, so that we know what happened at what point of time on any job that gets triggered. Um, the way you can set up this is, before we do that, I want to show you guys the architecture. So this is the architecture. I can send it to you guys. So there is data sources. these are the data sources that usually comes in: S3, Kinesis, external APIs, on-prem systems. So that's the initiation of this framework. Once we get the data, it's been sent to event bridge here using whatever ingestion layer that you want to use, whether Kinesis API gateway or S3 event. And then from the event bridge, the agent orchestration layer is going to spin up. And so the initial one would be like planner, which gonna plan, then the executor, monitor, learner, and all. These are the LLM agents, which is going to determine how the entire job is going to run. I'm using Cloud Opus, but I didn't update the diagram, and currently I shifted it to 4.5, Opus 4.5. The reason I changed to Opus, I started with GPT, but 4.5 seems to handle better context when given all the historical runs. It can handle better context. It can say it is deciding better servers to spin up, smaller size, better. If it's a memory intensive job, it's choosing memory optimized servers. If it's a like a disk intensive job, it's choosing that. So it's doing better. So I chose that. So this is the step function. So it's gonna spin up each and everything. So basically, AWS step functions is basically a orchestration layer which doesn't stop until the entire state is completed. So the problem with the lambdas is it has like a timeout of 15 minutes. So when something spins up, it stops after 15 minutes. But step functions make sure that it's completed until however long it takes to complete. So that's the compute layer, the ECS cluster, where everything, all of these will be run like. So the step functions triggers the lambda triggers this ECS cluster, and then the cluster spins up these jobs. So basically, there's like an ECR container repository where we store all of our Docker images in there. And then when this ECS spins up these jobs on Fargate, it spins off these instances with these worker nodes, and then starts the jobs on them. Once everything is done, you can also choose on demand, like I mentioned, fallback, and you can also determine if it's a GPU workload. You can spin up GPUs if those are available over there. So storage layer, so there's like there's S3 storage, and then there is DynamoDB, and there is cache, Elastic Cache is Redis. So the most important thing is for the jobs is DynamoDB, because we're going to store all of the pipeline status, which fails, what ran, what failed, what happened, what instances was chosen, like everything. That's the info that's our vision into these pipelines. The monitoring layer, we have CloudWatch, which shows like all the logs and all of that. Yeah, so that's basically the architecture. Let me go back to the PPT. Yeah, coming to how you want to use it, like I mentioned, there's like a number of use cases. The most important thing is handling spot instance interruptions, because if a job fails in production workloads, it's a P1 issue. We don't want to deal with it. So obviously, every company tries to like uh, make sure it doesn't matter if it's like 80% expensive, they still go with on demand. So that's the problem this framework is going to solve. You're using spot instances using LLM agents. Okay, there is also code in the repository. I can provide if you guys want to test it out and play with it. But any questions?
We got time for a couple questions. Any questions about cost agents?
Yeah, sure. Yeah.
I read that you use JSON contracts for agents to communicate with each other.
Yeah.
How does that work?
So it's basically, let's say there are multiple agents running in there, right? So there is like a selection agent, there's a prediction agent and all that. And there's a learning agent. So when when the selection agent decides like, hey, I want to select these instances to run this job, the first thing it's going to ask is like the learning agent, like, did it save anything for me to like choose? If it's saying like for 100 GB files, if it's coming from this company or this size, if it's the metadata it has on the file, so the learning agent says, okay, for this kind of metadata, use this kind of instance. So the selection agent might get like 100 instances types it can select from, but what is the learning agent saying? So it chooses from that, and then, okay, this is the better recommended approach, so let's go with these 4 instance types for this job.
Related to this, I guess, you use JSON. Why not YAML? I know it's a dumb question. I worked with multi-agent, and I found that in JSON you just add context that
The reason in JSON is most of these are exposed using APIs, and API talks in JSON, so that's why you
say it.
yeah. You have a question?
Yeah, I was curious about the implementation of this with by swapping out consecutive thinking agents with like diffusion agents. Have you like seen any diffusion models? Or like
No, I didn't try anything. Any other questions?
Got one.
Yeah.
So I saw that you had the observability
Yeah,
and you're logging all the reasoning and stuff like that.
right.
Why?
It's very important, right? Like, because you don't have any visibility. Usually in the pipelines, we determine like the how many instances this pipeline needs, which AMI it needs to use, what instance it needs to select. Everything is predetermined. We kind of code it into these pipelines when we deploy them. But here we're not doing anything there. Like, we're saying the agent should decide those things for us. How many agents it spins up, what type of instances it spins up, and why it's doing it. So for us to understand, tomorrow, let's say the job ran for like 4 hours instead of running for 30 minutes. The big question mark is why. So for us to see through those things, we need those logs. We need the observability. Like, okay, if it's doing whatever it's supposed to do. If let's say the job fails in between, like, we need to know why it failed, and all of those things. Yeah. So that's kind of a mandatory.
My follow-up is, so you have the massive architecture there. Where exactly in that is the human in the loop?
There is no human in here. So once everything is deployed, it's basically so once the file comes in from whichever the data source it has, the framework takes it from there. So there is no the human is there until it's deployed, but once it's deployed into your AWS account and it's productionized, there is no human.
So the thing just runs, and if there's any issues, that's when the human comes in.
Yeah, it basically alerts the whoever it needs to get. So the one of the important thing of log monitoring and logs is we need those alerts as well. So as part of that, we'll get those alerts if something fails. Any other questions? Okay, thank you. Thanks for the opportunity.